So I think the evidence comes in the form of what is it you actually see happening when you put this into a life cycle scenario. In the upper right-hand corner, if the slide could be bigger, it would show you that there's a tiny little blue bar chart over on the left that's showing what the physical part is that's actually being consumed. What you see, the biggest charts here are the bars on the red and the green are the actual virtual instances of the storage that isn't physically consumed but presented to the virtual desktop infrastructure as available. And you can imagine that with all of the images that everybody's got on their hard drives in a desktop that's been virtualized, there's an awful lot of common information. Why not take advantage of the fact that if you write it to the disk once, that you never have to write it to that drive again? On the bottom, you can get another example of this very visually, and that is that on the green is all of the activity that's taking place in terms of asking the drive for something to do, but the red slice, the very, very tiny part, is what actually has to happen to the media through our software. Now, this is an impressive result because what this is doing is providing, again, that equation I mentioned earlier of lower cost, high performance, so there's no penalty to the infrastructure, and what we're doing is giving a user an option to do something that they once would have been eliminated from having a personalized experience, because why not give them their ability to do their own installation of applications? Why not give them the ability for them to ask for applications that might be for their department? Why not give them the ability to use things like are available in System Center for them to add applications as are necessary? And what we are doing here, that becomes a different reality to how you can architect a virtual desktop infrastructure. So something here, I think, yep. So just want to make sure you're aware. So this was in the previous session. I thought it might be important for you to get what we have are real numbers on this. So from a reads perspective, 100%, if you looked at this, 450,000 IOPS coming off of our offload engine. That is with a 0.5 millisecond latency, and that is with a 4K block size. Okay, so we're not inflating the block sizes or the payload on the IOPS. The mixed is about 250,000 with about 0.75 milliseconds. So again, we're not inflating either of the numbers. And on 100% write, 200,000 or about just under 1 millisecond of latency. So these are the kind of performance numbers that we're giving you at the benefit of saving the space and giving the reduced infrastructure. Okay, so with that, I want to thank you all for coming down and taking interest in hearing about what we're doing.
Any questions? What's the physical hardware look like? What's the next best solution?
So the interface to the I/O offload engine is iSCSI. We use a SAS backend from the controllers to the JBOD. There's a NFS and fiber channel versions that are currently in process as well. And the latencies, by the way, on the fiber channel would be even less.
This is an endless solution. This would be a SAN.
You would call it something like that. What, though, would be interesting is if for folks who say, oh, I've got already an implementation, I've already got a storage system, how do I work this in? Well, one of the things that might benefit the infrastructure that's already in place is to use that for perhaps folder redirection, where the speed of the infrastructure is perhaps less critical. However, just because I didn't emphasize it doesn't mean we can't dedupe that too.
I mean, it is a SAN, I totally agree with Michael, but at the same time, it is in line in the sense that we're ingesting, the reads and the writes as they come in to your hypervisor. Do you want to talk about the hardware at all?
Basically, we've been going through a re-architecture from the standpoint of leveraging some of the industry leading components, in this case from Dell. So the components are made up of a pair of R620s and an MD1220 disk array. Actually, Dell services the support contracts. You can get pro support on the ingredients that are used for this. I mean, our value add really is the software infrastructure that you're seeing us put on top of all of this stuff. Mm-hmm. That's correct. Yes. Yes. This is coming, we layer on top of an ESX hypervisor.
Here's a slide. So there's a visual representation of what it looks like. So it basically loads as an OVF file on top of your existing EXX environment. And again, that inline process in terms of the ingest engine, it handles that, and then the compression and the deduplication. It's basically a data. It serves as a data store. So it's basically a volume on your EXX server. One more, I think we're out of time then.
Good. Well, we welcome you to come by. Please stop at the booth. We're over near the food. Again, thank you very, very much for your time.
This is really not. You tease it over there. This is crazy. Yeah. You put it in your pocket. And again, just turn it on before you speed.
Was that one already on?
Yeah. That's for the camera.
All right.
Good luck.
I don't need to click around, just hit the button. Okay, get started whenever? All right. All right. My name is Mike Chudzik. I'm a systems engineer with PureStrage. Next on the deck here. Flash for all. What PureStrage is all about is we are a 100% all-flash storage array. So where the whole flash for all thing comes from is typically flash or SSDs, people think it's very expensive, so I got to pick niche use cases where I can deploy it. What we're doing is we're making flash affordable to the point where you can deploy it anywhere in your enterprise. So we want to build an all-flash enterprise storage array that has the same price point as spinning disk. So virtual desktops are better. There's not a lot of debate out there. Virtual desktops are more secure, more reliable, and can help reduce your administration costs. So there's a lot of obviously momentum in customers deploying virtual desktops. But the issue is that virtual desktop infrastructure will kill your storage. It'll generate tens of thousands to hundreds of thousands of IOPS, bursty in nature, so unpredictable bursts coming from login storms, boot storms, virus scans. It's also highly random, so traditional storage array architectures have a hard time keeping up with that much random I/O. And then the read-write characteristics are also a little unusual compared to traditional workloads in that it's very write dependent. So there's a lot of heavy writes being issued by the virtual desktop infrastructure. And what ends up happening is the cost of the storage to be able to deploy VDI ends up killing the VDI project. So what you see happening is pilot projects being implemented on traditional storage architectures because you got a little bit of storage capacity out there, maybe 50, 100 users, everything looks good. Once you try scaling that, the demands on the storage infrastructure just kill the project. Poor user experience. If you're sharing the storage array with other applications, you could be affecting other production applications, whether it's SQL Server or Exchange. But then the cost of the storage to fix that ends up driving up the cost of the project. So what ends up happening in a lot of cases is the pilot looks good. When you start doing the math on what it's going to cost to fix that by throwing more spindles at it, it kills the VDI project. And what ends up happening is over $200 to $300 per desktop just for the storage component really is common out there when you're looking at traditional disk architectures. So in a lot of cases, that going from pilot to production, it's very difficult because of the cost involved. So with PureStrage, we're an all-flash array, and we are the ultimate storage for VDI. Being all-flash, you're going to get great performance. In a lot of cases, we've had customers tell us that the performance of doing VDI with PureStrage as the back-end storage platform, the performance is actually better than local SSDs and laptops. It all comes down to how you manage that flash. There's a lot of things that happen with SSDs that can cause unpredictable performance. Our storage platform is engineered around those issues to deliver consistent front-end performance. So hundreds of thousands of IOPS at the ready. Even if your workload doesn't demand 100,000, 200, 400,000 IOPS, it's something you'll never have to worry about in terms of being able to deliver that kind of performance. So we can handle all those peaks, the boot storms, the login storms, software patching, virus scans. There's plenty of horsepower available to satisfy those needs. We make it affordable, too. That's the key thing here. being able to offer an all-flash storage platform at or below the cost of spinning disk. And the way we do that is with data reduction. So we're doing inline deduplication, we're doing compression, we're doing pattern removal, everything we can to squeeze that data footprint down. And what that does for us is a couple things. Number one, it lowers the dollars per gigabyte cost of the array. All right, so we're going to be less than $5 a gig. If you compare us to traditional spinning disk fiber channel drives that you want for performance, we're going to be at or below that cost, especially in VDI, because the data reduction rates with VDI are so tremendous. Typically at least 7x. Even for, in a view environment, a link clone environment I have running up in Michigan is getting about 7x data reduction with 1,100 to 1,200 VDI users. So at that data reduction rate, we're cheaper than spinning disk. Using persistent desktops, data reduction rates go up even more. All right, so we're even much less expensive than spinning disk. And the other thing I point out here is persistent desktops equals link clones. Because we do data reduction, we're doing dedupe and compression, we don't care if you're doing persistent desktops or link clones. You're going to consume the same amount of physical capacity on the array. So you pick and choose how you want to deploy your VDI environment for what makes sense for your users. We're not going to push you in one direction or the other, and you're going to get the same performance no matter which way you go. Scalability and reliability, that's critical. Once you start centralizing this infrastructure, you want the scalability, you want the HA, you want enterprise class quality of service from your storage array. No downtime. So we support non-disruptive code upgrades, non-disruptive hardware upgrades. So everything is non-disruptive on the platform, and we can scale an array from supporting hundreds of users to well over 5,000 users in a single storage array. And then lastly, making it very easy to administer. We have a vSphere plugin, so you can manage the entire array from within vCenter. And just making it very easy to administer so that if you wear multiple hats, if you're the storage admin and the VM admin or the Citrix admin, you can manage it all very easily so that it doesn't require extensive training. Typically, knowledge transfers for customers after installation is 10 to 15 minutes, and the customer is very productive and gets great performance out of the array. What you've been seeing with Flash over time is a real convergence of both niche appliances or PCIe cards that are all Flash, deliver great performance, but then your traditional disk arrays have gone from wide striping arrays to implementing some type of Flash cache or tier. And like I said, it's a real convergence of these two different approaches into an all-Flash array. When you compare what an all-Flash array can do with what legacy disk can do, you're going to get 10x the performance. You're going to have much less space consumed by the array because of the data reduction, and you're going to consume significantly less power and cooling. If you compare the OpEx for an all-flash array to a traditional disk architecture, you're going to save somewhere in the order of 70% of the OpEx for power and cooling. And we also make it much simpler to administer. So saving a lot of time, you're not having to worry about and tune and manage your storage. If you compare us to your original Flash implementations, PCIe or Flash appliances, you're going to get better scalability, more resilient capabilities, so HA, non-disruptive everything. You don't have to re-architect your application. Things like host array block alignment, they don't apply to us. We always get great performance whether or not things are even aligned. And then it's also significantly less costly than the original Flash implementations. At a high level, 4 main focus areas for Pure. The first one is all around game-changing performance. For us, and for me personally, it's not necessarily about the high-end IOPS. We're not going to promise you 1 million IOPS. Most customers don't need 1 million IOPS. It's more about the latency. That's what's going to dictate your end-user performance. If that storage platform can deliver consistent sub-millisecond latency for reads and writes, that's what's going to make your users happy. And we do it with 100% MLC Flash. All right, so we're using basically what amounts to consumer-grade Flash, hardening it with our controller software to deliver enterprise qualities of service. Less cost than disk, I've talked about that, especially in VDI environments. Right? We're not just a VDI play. We have customers using us for databases and virtual server, just general purpose storage. In those environments, your data reduction rates aren't as great as VDI, but there's still a great application there where we can be at the same price point as spinning disk. VDI, we are cheaper than disk. Enterprise reliability, full HA, can't say this enough. In an enterprise storage array, you want HA active controllers. You don't just want redundant components. All right, 2 physically separate controllers. Being able to do non-disruptive code upgrades, non-disruptive hardware upgrades. To add capacity, it's as simple as racking a tray of SSDs and turning it on. Within 30 seconds, the capacity is there and usable. And then a 5-year lifespan, engineering the product so a 5 to 7 year lifespan is acceptable and doable. But just like any other storage array, you have a service contract, right? If an SSD fails or a controller fails, we come out and we replace it. And then lastly, unexpected simplicity. Just, customers expect great performance from a flash product. What they don't expect is just how easy it is to administer. If you design the array from the ground up around flash, you can do a lot of unique things as far as how to make the array very easy to manage. This slide I could spend half hour on, I could spend 45 minutes on. I don't have that kind of time, but the whole point here is the product is designed with commodity hardware. So Intel processors, Samsung SSDs. The real engineering that Pure does is around the software that runs on the controllers. So no host-based software required here. This Purity operating environment is the software that runs on our controllers, designed from the ground up around flash and the things that can happen with flash. If you look at our pedigree in terms of our founders and early employees of the company, our CTO is John Culgrove. He was the technical founder of Veritas. He wrote File System, Volume Manager, Cluster Server, so all those great storage products. One of our very early employees is a gentleman by the name of Michael Cornwell. He was the lead flash designer at Apple. So he was Jobs' right-hand man putting flash into iPods and iPhones. So having that kind of deep understanding of flash, as well as the storage expertise from Kaz, we designed Purity specifically for flash. So there's not any traditional disk technology in here, and we just swap drives with SSDs. It's all designed around flash. So benefits of Pure Storage throughout the day, being able to handle those boot storms, the login storms. Talking to different customers, a lot of the customers have different pain points. One customer I worked with had issues with log out storms, where at the end of the day, everybody was leaving and just took forever for those desktops to shut down because of the log out storms. Being able to handle virus scans, software updates. There's plenty of horsepower in the array to be able to handle these kinds of peaks as well as normal activity throughout the day. What's great about the technology also is we're able to deliver small block I/O with very good low latency. At the same time, they're able to deliver high bandwidth operations that don't necessarily care about latency. They care more about wall clock time. How long does it take to do a virus scan or a software patch? So being able to deliver that consistent latency for users even while these background things are happening in your environment. I encourage you to go to our website. We have a great solution guide out there that walks through a lot of the benefits of using an all-flash array for VDI, but then we also have reference architectures out there. Being able to scale from a single controller, half-populated tray of drives in a pilot phase where we can support hundreds of users in 2.75 terabytes of raw flash, getting roughly 10 to 20 terabytes usable. Again, that's after data reduction. But then being able to non-disruptively scale that to a go live by just adding in a controller. To go from a non-HA to an HA configuration is as simple as racking the new controller, cabling it, and turning it on. Zero downtime. You're immediately HA. But then being able to expand that to over 1,000 users, 5,000 users just by adding capacity. Again, non-disruptively, zero downtime. So some great stuff out there. We are certified for VMware and Citrix. We are not, we can support traditional physical servers on top of VDI too. So a lot of customers will start out with VDI, maybe 300, 500, 1,000 users, but then there's still plenty of horsepower available, so they'll run virtual servers on us, or maybe they have some physical SQL servers. So we're Fiber Channel and iSCSI only, and we can support basically any platform that can talk those protocols. That's it. Any questions? No. Okay, so we have a booth in the vendor area there. We've got an array up and running there. If you want to come check it out, touch and feel it. It's all there. Thanks. Here, I'll do this. I'll get you here. Yep, yep. I'm having a hard time seeing this. This is the mic for the room. It's off right now. And this is the mic for the camera.
we go. I got one. Okay. Alrighty, hi everybody. I am Justin Lauer, I'm with Tintri. I'm here local in Chicago. Anybody else from Illinois, Chicagoland area? Okay, good, you're the first person I've seen the whole week so far that's local. I'm here to kind of give you a little bit of background about Tintri, and my guess is not a lot of people probably have heard of us or know what we do. So I'm going to start with the basics. You know, who are we? What are we trying to do? Why are we doing this? Ultimately, how might this resonate with why you're here at BriForum this week? So the first thing is, you know, who are we? Why did we do this? We were born out of the vision of the original VP of engineering from VMware, a guy named Dr. Kieran Hardy. He pretty much ran VMware engineering for about the first 8 years of the company, and his whole vision for Tintri was born out of the struggles he saw during VMware's huge growth phase, being that the virtualization stall he saw happening was typically attributed to traditional storage constructs and their complexity or cost when sort of tied into a virtualized environment. So his whole idea was, what if storage was just purpose-built from the ground up to do one thing and one thing only, service the hypervisor and all the virtual machines that live on top of it. And that's what Tintri is. We are a storage appliance, specifically laser-focused on the hypervisor market. So we don't do anything in the physical world, nothing in the mainframe world. We were built from the ground up to solve the challenges of virtualizing. So really our whole mission is to help you guys virtualize more, virtualize faster, and simpler than you've ever been able to do before. However, we're doing that through storage. I could go through all the great people we have there. The whole point here is we've built possibly one of the best engineering teams in Silicon Valley with the virtualization and the storage DNA we have. You know, some of the great people that I do want to take a second to point out, specifically Ed Lee, right? Original Berkeley RAID team. This guy is a living storage genius. He wrote the first RAID driver known to man when they built Franken RAID back in the day at Berkeley. Ironically, it's actually in the Computer Science Museum out there in Silicon Valley. You can see this giant monstrosity of a RAID array. So kind of what is our approach, right? What are we trying to do? We certainly are using Flash like everyone else. But what I'm not going to do is sit here and talk to you today about my Flash is better than your Flash story. I'm going to kind of give you a little bit of an idea of how we think storage is kind of matters to our consumers. And that's really this concept of zero management. And we think that's enabled by three things, basically. Storage intelligence, infrastructure insight, and VM control. And really what this ultimately means is storage that's always optimized, something that doesn't really need to be managed from day to day, something that's always understanding and knowing the requirements of the resources or workloads you're putting on them. That could be a virtual desktop, could be a virtual server, could be whatever you decide to run on it. Mixed workloads was what we were pretty much designed for. So I'd probably say about 65% of my customers run both VDI and traditional server virtual machines right in the same place. So what this actually means is, you know, on the storage side is, yes, taking advantage of Flash, right? But Flash in and of itself isn't a magic Band-Aid for the data center. You can't just throw Flash in and all your problems go away. There's got to be some extra level of intelligence and manageability that go along with the Flash. And for us, that's basically trying to get the most out of Flash on the performance side via quality of service mechanisms and performance isolation mechanisms. So not just saying we have really low latency and really high IOPS, but saying we actually want to understand all the I/O coming in from all the VMs and apply quality of service to that, right? If half of you guys are virtual desktops and half of you are SQL servers and you're all running on a Tintri VM store, I need to account for a giant boot storm, log on storm, recompose on the VDI side without affecting the I/O throughput latency requirements of all of the databases running. And that's something we're able to granularly do because we have this native ability to understand what a VM is. So the big sort of piece about infrastructure insight and VM control is we don't speak any of the traditional VM construct language. LUNs, volumes, RAID groups, they all go out the window. Everything we do, and you'll see this, I'll show you a screenshot, is done right at the virtual machine and virtual disk level. So essentially, with the performance thing working at a sub-VM level to kind of guarantee that all the resources are doled out, we also allow you to act upon those VMs, get visibility at the VM level, and ultimately act upon them. So really, the deal here is you don't have to be a storage guy. You have not know anything about storage to leverage Tintri. If you're virtualization savvy, if you understand the virtualization workflows, you'll log into Tintri and you'll see your VMs. You'll know exactly what they're doing. Our largest customer has about 300 terabytes of Tintri under management with no storage guys. So a lot of people say, hey, you mentioned VM awareness and the importance of doing things at a VM level. What does that really mean? And typically what we've seen in the industry is people point to these acronyms, right? These are all the vStorage API acronyms and all the things that VMware's opened up to their ecosystem of storage partners. And historically, this has been accurate, right? VM awareness has equaled these APIs. But what we've seen is these are becoming normal, right? Everyone expects these. If you're going out and looking for new storage and it doesn't support these, you're probably no longer considering that vendor. These are the things that are the new normal. What we actually believe at Tintri is that in the absence of all of these APIs, if you can still show native VM awareness, then that is not what VM awareness is. It's not just integration with these. It's that in the absence of all the vStorage APIs, you still have native awareness to what a VM is. And what that really means is per VM visibility, per VM manageability, and most importantly, per VM quality of service. And that's all done without any of these extra APIs. We certainly integrate with all those because all customer community expects it. But what we're saying is without any of that, we have the ability to natively know what a virtual machine is. And this gets into, why do we do this? Well, what matters to your businesses? What really runs your businesses? Is it all the infrastructure and the hardware? Well, that's required, but the only reason we have that is to run applications. And applications run inside virtual machines, right? Since 2009, we've seen this crossover point. More VMs were deployed than physical servers, and it's just gotten exponentially increased year over year. So for us, we're basically saying, why bother focusing on all of the hardware when really what matters is the application your end users use to run your business so that the business can turn a profit. And that's ultimately why Flash is even relevant. It's to make applications go faster. And we're certainly focusing on that. Everything we focus on is at that virtual machine level. It hurts me to say that a little bit because I'm an infrastructure guy. I came out of that world. But I realized that my business when I was on the customer side ran based on the software that my end users were using. They didn't care about what was in the server room. So if we look at our file system, I'm going to go through this quickly unless you guys really want to pick into this. But our whole story around Flash is to make Flash viable in a hybrid configuration. We are not an all-Flash vendor. We are hybrid, but we do no caching and no tiering. We treat Flash as a first-class citizen. For us, it's about fitting as much of the working set of data into Flash as possible while applying those quality of service mechanisms on the way in at the VM and sub-VM level. So our goal here is to deliver a 99% Flash hit rate for reads and writes without having to be 99% Flash. Essentially what happens is on the curve of Flash hit rate, when you look at all disk, you look at sort of the general market of caching and tiering, you look at all Flash, we're about 1% away on a Flash hit rate. So essentially, we're giving all Flash look and feel without the need for all Flash. And this is definitely a leapfrogging of the traditional caching and tiering models. So it's even more, we think we're delivering ultimately the same ballpark of latency and IOP performance as all Flash at a fraction of the cost based on the fact we're not all Flash. Meanwhile, we're also adding in that extra. Remember I said Flash isn't a magic Band-Aid. It's the what else are you doing? And it's all of the per VM capability, quality of service, per VM snapshotting, replication. So when we look quickly at a snapshot of the dashboard here, what we'll see is I'll see an individual virtual machine. So what you would see here is a list of all your VMs, right? You don't have to go to LUN32 and know that the SQL server's on there. You'd just see it, or you'd see your 750 virtual desktops. We can go right to that, get exact numbers for I/O, throughput, latencies, And then we have all the actions we can perform right on that virtual machine, right on storage. So snapping, replicating, cloning. All of these things are sort of first, right? Being able to actually do on hardware per VM replication. Traditionally, that's only been enabled through host-based or software-based solutions. And then, of course, all the metrics associated with it. And really one of the hidden gems is this concept of auto-alignment, right? We will automatically realign misaligned VMs, something that typically you either forget about, you don't know about, or you have to go back and do after the fact, and it can be a nightmare, right? We have a customer here locally who had about 1,000 misaligned Linux VMs. They could not take downtime to fix any of them. Their solution was just to simply storage vMotion them onto Tintri, and they were done. They were fixed. In terms of architecture, this gets back into some of the simplicity, right? If you have a VDI project, you probably went through some exercise like this to determine, or your storage guys did, to determine some layout. And on paper, it looked solid, and then the day you had deployed it, much like Mike said, things changed, and all of a sudden this wasn't relevant anymore. You either had to scale it up, or it wasn't meeting the performance requirements, you had to build it out. We're basically saying do away with all of this. Think of Tintri as one giant, highly intelligent, high-performance bucket. Just dump all your VMs in, and the file system will deal with the quality of service mechanisms and figuring out exactly what resources are needed for each individual virtual machine at the right time. So again, one giant request for I/O or throughput isn't going to kill latency for all the other VMs. We basically do away with the noisy neighbor problem because of this per VM capability we have, because we're able to intelligently apply the flash to that in real time. What this really means is we get away from this, right? Carving out classes of service for storage, classes of service is the data store level, and we move towards more of an interchangeable model, right? If each Tintri node effectively is a giant data store, if we said we had 4 Tintri nodes, it wouldn't matter where we had the VMs. They would all be greeted with that 99% flash hit and that quality of service at the VM level. So instead of applying policies down here, we're dealing with managing VMs here. So a VM, a virtual desktop server, could live on any node at any time and still get the same level of performance. And the policies that would be applied wouldn't be applied down at the data store, LUN, or volume level, right? We wouldn't apply a snapshot policy on the back end storage volume. We would do it on the back end storage, but at the level of a VM. So the vision here is that that policy would follow the VM if it ever migrated to a new node. Today, if a VM migrates to a new data store, it inherits whatever policy is on the underlying storage. We're trying to make all of this interchangeable and transparent. Again, more along the lines of the workflow of the VM admin. And that's really kind of conceptually what we're doing. We do have a live demo going on at our booth, so if you wanted to dig into kind of the UI and kind of see some of these things in real time, I can do that for you. Otherwise, I'll take a few questions and let you guys get to your next session. Thank you.